Hello and welcome to the Algorand Proof of Stake Show, a show by algo devs for algo devs. Here we explore the current state of the Algorand ecosystem by focusing in on interesting projects building out the decentralized future. I'm your host, Ryan Fox, developer advocate at Algorand. Today, we're going to explore Algorand smart contract security audits with the team at CertiK. My guests today are Boxi Lee, senior engineer, and Monier Jalal, vice president of marketing. Good afternoon to you both.
Good afternoon.
Good afternoon.
Glad to have you both here. Boxi and Monier are going to be introducing the algo devs to the audit and security services on offer from CertiK. Their mission is simple: secure the Web3 world. They are well on their way, having worked with a number of Algorand-based project teams, including Opolis and next week's guest, Teller. Founded in 2018 by professors of Columbia and Yale universities, CertiK is a pioneer in blockchain security, utilizing best-in-class formal verification and AI technology to secure and monitor blockchain's smart contracts and Web3 apps. We've got lots to cover here today with the CertiK team. Welcome, Boxi and Monier, to the Algorand Proof of Stake Show.
Thank you. Thanks for having me on.
Hey, Monier, let's start with you. First we met back at the Algo Ranch in Denver earlier this year, and I had the opportunity to learn about your background and the history of CertiK. And I'm wondering if you would have the ability to share a little bit about yourself and the history of CertiK in the field of auditing smart contracts.
Absolutely, and it feels like a long time ago since we last saw each other. But
isn't that true?
Appreciate you having me on the show and having Boxi here as well join us. So I think you started off pretty well in just stating what CertiK is and how it was founded in 2018, of course, with two professors really pioneering the way in technology around formal verification, using that for security purposes, and then around auditing and using that to effectively find more vulnerabilities at scale. That was 2018 timeframe. Since then, we've moved on to a lot of bigger, more stuff. And so we tout ourselves as the end-to-end security player in the market. We don't just do auditing, although we'll talk about auditing today. We cover a lot of things. So in the entire life cycle for Web3 development, we start with auditing, but we do other things. We do bug bounty now. Surprise! So, if you go take a look at our website, we actually do bug bounty programs. Given rug pulls and scams now that have happened, been trending, we now do KYC verification for project founders and owners, making sure that the community can trust those founders and owners. So that's another piece of it. And then when you get out the door, once you launch, we're actively monitoring 24/7 for any suspicious activity, sentiments are happening around your project. And continuously scanning at the same time for changes. So it's an end-to-end solution, continuous monitoring, continuous scanning, and we're kind of the one-stop shop for everything. If you go look at CMC, CoinMarketCap, we actually cover 70% of the top 200 projects, which is a lot. In terms of scale, we're around near 4,000 clients total, and we're all over from large to small. We probably covered in cap in total 300 billion, secured 300 billion. And so, a lot of that people question is like, oh, how do you guys do that? How do you scale? How do you go so fast? And a lot of it is the backdrop of what we do at CertiK is the infrastructure, the reliability, the resiliency. We actually audit our own auditors, believe it or not, which is crazy, right? But we're checking for quality, always checking for quality, and we're running automations to double check things and push things through. And so, you look at the market today. Sure, there's a lot of auditors out there. I think that's great, and I think everybody's doing the right thing. It's not a case of just getting a certified rubber stamp, so to speak. It's actually looking behind the scenes as the reliability, reputation, and at scale. Some of these vulnerabilities are really complex and hard to find. So finishing an audit doesn't mean like, yeah, it's a pat on the back, go for it, launch. Is how well that audit is and what it's found. And more so for projects is whether you remediate those or not. So we're not in the game of forcing people to fix stuff. We're reporting stuff, and it's up to you to to audit, but also continue auditing if things change and another contract comes out. So yeah, I mean, there's a lot of things going on since 2008. But good to see you. It's a long answer for what we're doing, but hopefully that helped.
Yeah, definitely, and it leads right into to Boxi. I'm glad you're here today. I think Monier kind of alluded to it, right? I think you've got probably the hardest job in crypto, which of course is finding bugs in smart contracts. So I'm interested to know a little bit more about your background and how did you come to start working on auditing Algorand smart contracts for CertiK?
Yeah, so I've been working at CertiK for more than 3 years, and at the very beginning, I focused on software development on security tools. Like, I guess it's not the current version; it's like the previous version of the formal verification engine. And then I switched my interest to security auditing in 2020. So for Algorand, like early this year, around April, March 2022, we started like onboarding the Algorand from the whole tech stack to the community, and we start working on the security audits on Algorand.
Great. Hey, Monier, of course, the algo devs are out there building all the time, and I'm wondering, how do you engage with project teams to inform them about what your offerings are, and then also, like, when is the best time for those teams to begin their engagement with CertiK?
That's a great question. So we're active and proactive in engagement. We're in and around the community doing some cool stuff with spaces, with projects, and getting insights from their point of view, where the challenges are and where we can help. We're continuously doing that. And if you look at our Twitter accounts for community, you'll see just active spaces, almost daily that's going on. And it's all about that. It's all about understanding where the challenges are and what we can offer. In terms of just where to start, it comes further back in the development life cycle before even an audit happens. Is just education, is being able to understand, okay, security is not a sexy word, right? It's not a developer's word that there's top of mind, but just understanding what is secure coding is important. Being able to say, okay, what's the best practices for coding securely, and what should I do to stay secure? Being able to do reviews, being able to have checking specifications and reviews, and then coding and looking for certain flaws, being able to have an independent team that is a security team doing threat modeling around what you're trying to deliver and come up with some recommendations. All that is just comes for free, right? If you do your job correctly. When should you start? And obviously, before you launch, you should audit, and that's going to be where things are discovered. It's up to the team to recognize the timing around that, because obviously you don't want to just wake up and say, hey, let's launch tomorrow, and go, oh, by the way, I need an audit. Audits do take time, depending on the amount of stuff you're auditing, the complexity around it, all that good stuff, the eco, everything. So typically, you're gonna talk to us early as possible, and we have conversations with teams that are basically as farther back as, hey, I have an idea, and somewhere down 6 months from now, I'm going to have a launch. When can we talk? And we'll say, let's talk now. And so the last part of this is really we like to stay partnered along the way, because things do change, and so we stay connected and be able to give advisory recommendations to security, one thing, and also lock in at the right time when auditing is there. So yeah, that's pretty much it.
Good. And Boxi, to you on the dev side or on the audited side, more specifically, what can you say to the algo devs that they could do, early on in their development life cycle that might help them benefit them when it comes to the end, when they're actually getting to that audit process? What can they do at the beginning?
I would say at the very beginning, the most important thing is to decide what project they are going to do, and they come out with a very in detail design doc. So in their development cycle, as well as in, for example, they are coming for us for auditing, and in the auditing cycle, the design doc will help a lot, definitely.
Great. Wonderful. Well, I know that you've got some demos to go through, another presentation to go through. So, Boxi, why don't I turn it over to you, and we'll get that started now.
Thank you, Ryan. And hi there. This is Boxi. I'm a senior software engineer at CertiK. Like I just talked before, I have working in CertiK for more than 3 years, and early this year, we kicked off the initiative on Algorand security, as we are seeing the growth on the ecosystem and on the technical community side. So now I'm serving as one of the tech leads for the Algorand auditing division. So that's why I'm here for the presentation. And our current auditing service has covered Teal, the native assembly language for Algorand virtual machine. We've also covered PyTeal, the Python package that allows developers to write in Python and to compile to Teal. And lastly, we also onboarded the Reach that happen to be loved by engineers with traditional Web 2 cybersecurity experiences, given that their primary language is JavaScript in the past. Yeah. And here is the table of contents of what I'm going to talk about today. As you can see, there will be general auditing methodologies, common issues that we found in some public Algorand smart contract repo, and also in our client's code. And there will be 3 examples in the end. So first, general auditing methodologies. People are always curious about what we do when audit. So first, we leverage our automated tools developed by our in-house engineers. The tools aim to cover a wide range of generic security perspectives. This helps to increase the quality of the assessment. And second, we do manual reviews by our engineers that focus more on the business logics and attack vectors. So for the automated tools, the tools are integrated with our internal auditing platform that serves as a workstation for more than 100 security engineers in the company. The tools include formal verification, static analysis, role-based checker, similarity checker, etc. These automation solutions are built and maintained in-house, and we expect more to come out serving the other needs. So the process is when the smart contract source code to be audited is confirmed, the data will be pushed to the tool side and trigger the processings in parallel. Different tools will return different outputs, like flow diagrams that can help better understanding the core logic, security concerns that can recommend the auditors to pay more attention, and finding that can be drafted to the report. For findings produced by the tools, we are required to review the details and validate the correctness before putting into the audit report. The feedback loop will also feed the tooling side to improve the coverage and further reduce the false positives. And that is about our tools. For the manual review, we follow our auditing guidelines. Our engineers will also do pair reviewings in different stages, since each auditing project requires at least 2 security engineers to complete. And for the guidelines, at the very beginning, we read the design documentations and play around with the front-end DApp of the project if there are any like front ends. And that is like why I said design docs are very important in the auditing cycle. So we view the design doc and the front end as the truth of facts provided by the client. We try to understand the project as a whole from a high level, as well as the user stories and user endpoints at this step. And then we will dive deeper into the source code. So firstly, we read functions as if they are standalone. Then we will pretend to be normal users to check if a desired end can be reached through a happy path. We will also pretend to be hackers to see if there are some special orders of calling functions that can break the logic or manipulate user states or application states. And the whole above steps are called micro-auditing. It requires us to read through the code line by line and completely understand why it is coded like this. Many bugs are found during micro-auditing. After that, the goal is to understand all functionalities of the project in general. As the final step, before writing the report, we also do macro auditing to find global vulnerabilities. We search for all occurrences of each state field and each function. We analyze the read and write accesses. We check different what-if conditions. For example, can the attackers prepare something strange, like an imbalanced swapping pool? Can the attackers avoid some checks and execute some unauthorized functions? How is the user rewarded, and what can be withdrawn? Something like this. For the security findings, whose severity levels are medium or plus, we usually write our proof of concepts. It could be some code snippets to simulate the attack and exploit the vulnerabilities. And next, common issues. Here is the list of some common findings. Some of them are general issues that can also take place on other languages of other platforms, like integer overflow, access control issues, or random number generator issues. And some of them are specific issues on Algorand, like the 700 opcodes limit per transaction and 256 inner transaction limit per transaction group. There are also some business logic issues, like different types of projects would have different common issues. I won't be able to go over all of them because of time, and also this list is not fixed, since we will add or delete more items like after new issues are found or after the languages are upgraded. So next, I'll move forward to the examples. The first example is a general not so good practice of coding assembly. It does not only happen to Teal. We can read the code together. So the first line labels the branch delete underscore app. A branch is a location that some other instructions can jump to. And from line 2, inside this branch, transaction sender pushes the sender address to the stack. and global creator address pushes the creator address to the stack. And then on line 4, the double equal sign will pop the top 2 elements of the stack. And if they are the same, then integer 1 is pushed back to the stack. Otherwise, integer 0 is pushed back. Next line, if the top element of the stack is not 0, then it will jump to the pass branch. So the checking of if the first element is the top element is 0 or not is described in the BNZ opcode inside the AVM. So, and if it is passed, it is jumped to the pass branch. Then integer 1 will be pushed and returned. So if we have the sender equal to the creator, then on line 5, BNZ pass, it will jump to the pass branch and successfully return. So we can see the success case is correct. But if the sender is not the creator, then on line 5, the BNZ pass will not do anything. Instead, the code will not stop. It will continue to line 8 and 9, and finally has integer 1 pushed and returned. So one possible solution is like this. The error opcode will revert the transaction, and the edge case is well handled. There are, of course, many other different alternatives to fix the issue, and that is totally up to the coding style and the coding habit of the developers. Next, this is the second example. This example is like the developer implemented a new subroutine, div w, wrapping the AVM opcode div mode w. The inputs are 2 uint 128 numbers, and the output is 1 uint 64 number. And the inputs and the outputs are talking about the newly implemented subroutine div w. And to understand the code, we have to first understand what the opcode div mode w do. According to the opcode documentation, it's right here on the right-hand side. The variables A, B, C, D, and W, X, Y, Z are type of uint 64. The notation A, B indicates that 2 uint 64 values A and B are interpreted together as 1 uint 128 value, with A as the higher uint 64 and B as the lower uint 64. So in human language, div mode w is dividing the AB number by the CD number. And the results are the quotient is WX and the remainder is YZ. And let's look into the code. So suppose the top 4 element is ready in the stack, waiting for the call of the div w subroutine. At the beginning, we have DCBA at the top of the stack. And after div mode w is executed, we have ZYXW at the top, where W is first pushed and Z is last pushed. In other words, Z top element and Y is the second to the top element. So after div mode w, the pop opcode will execute twice on line 3 and line 4, where X is the top and W is the second to the top. So next line, the locations of X and W are swapped. So the top element is W now, and it is popped out by the last pop opcode. And therefore, 7 of the 8 variables A, B, C, D, W, Y, and Z are all popped. And X is the last element to be a return sub opcode. So here, X is the lower uin64 WX number. And W is truncated without any checks, being the high uin64. Our recommendation would be like always check if the W value is empty or not before popping it out. Otherwise, there will be a lot of like data loss during the calculation of deep W. And finally, we have the third example. This example is related to the business logics. So we can see on left-hand side, the stake function transfers target Algorand standard asset, ASA, from the sender to the contract. And there is a state variable, self.stake, which is updated after the transfer transaction. Self.stake means the sender's stake, and it is good to be increment afterward. And on the right-hand side, we have the unstake function. It works inversely. A user can take money back from the contract address by calling unstake. We can also see there is a helper subroutine send ASA from address in the bottom right corner. This subroutine works just like this transfer from function. So we can see in the stake function, the asset transfer direction is from the sender to the contract. And in unstake function, it is from the contract to the user. We noticed that there is a state variable self.stake that saves the stake amount of each user. So in stake, we add a new stake amount to stake. But in unstake, the subtraction from self.stake is missing. So it's like, for example, there's a user A. The user A can first stake an amount for 1,000 units of an ASA, and the user A can call the unstake function unlimited times as long as the input parameter of unstake amount is less than or equal than 1,000. This is because the self.stake local variable of the calling address is never updated in function unstake. The assertion check in the unstake function here, it requires the user underscore stake should be greater than or equal to the input variable unstake amount. Because the self.stake is never updated after the asset is transferred from the contract to the sender. So the self.stake is like, it can be abused. Always the amount that added when the user stake into the contract. So the user A can drain all ASAs from the contract eventually. And the fix is also simple, just like always remember to update all state variables after the transfers or after essential logics are handled. And that's all my presentation today. appreciate Algorand side have us to present today on the overview of Algorand security auditing. As having more CertiK engineers onboarded with Algorand Audits, we expect to contribute more technical contents to the community later this year. Thank you.
Well, wonderful, Boxi. Thanks very much for the presentation, really introducing us to how you do your job, and especially, going over those examples of some of the things that you find most common happening, and telling our algo devs how they can make sure that they avoid some of those common pitfalls. That's very helpful, and it's really interesting to learn, how you do your job as well. So. I know our algo devs are very excited to connect with you and the CertiK team. I know, as you said, we want to do that as early in the process as possible. So where is the best place that those algo devs should be connecting with your team?
As I said before, the best time is really as you start off in your design phase or somewhere in the middle of coding. By the time you realize what you're doing, it's mostly likely that you're at the end of it. it's sometimes too late, and so we do get surprisingly people come to us and say, "Hey, I'm going to be launching next week. I need an audit," and we say, "You should have talked to us a month ago or something like that, right?" And so, and I say that really with pretty much transparency here, because it is about how much code you have, the scope of it, the complexity of it. So when you come and just drop that and say, well, I need an audit, to do an effective job, we need the time, right, to do it. And so early as possible, start talking with us, and we can get you scheduled.
Well, good. I know we can reach the company at CertiK on Twitter. It's just at CertiK, CertiK.com as well. For you guys both on Twitter, if we want to reach out to you there as well.
Yeah, I mean, you can DM through our Twitter accounts, CertiK Twitter accounts. We have CertiK at CertiK and then at CertiK Community. DM directly there. You can email bd at certik.com. There's another way, and BD will reach out to you. You can go to our website and you can chat with the bot right there. We have a bot on our website, or you can actually form fill and ask for a quote, and somebody will reach out to you for a conversation.
Well, very good. Boxi Lee and Monier Jalal, thank you so much for introducing the algo devs to CertiK. It was a pleasure having you both on the Algorand Proof of State show today.
Thank you. Thanks for having us.
Thank you.
All right, algo devs, until next time, have fun building on Algorand.